Welcome to AP Computer Science Principles. And this unit we're working on the building blocks assignment. We're adapting this to our online course, so it's going to be a bit different from the original. In this unit, we're going to be spending time acting like a computer. As a result, we will see a preview of many of the ideas and concepts to come this year. The building blocks for the computer science. What we will model is input and output, step-by-step processing, memory, programming, and with that, algorithms and abstractions. But for now, just focus on the game and have fun. In the first stage, you will develop a plan. Consider the plan to be a set of instructions, like a recipe, or a storyboard, or a computer program. Only instead of baking a cake or writing a script for a movie, you're going to be programming people. Keep that in mind, as you will need to be specific. You'll use this time to create and test your solution. So try to find or try to anticipate any holes in this as you work through this step. Okay, we're going to have each student be given a unique program to solve. Students are going to write a single people program to solve their problem, and students should test and validate their solution as they develop their program. Okay, in the second stage, another student will execute your instructions. This means that they will attempt to follow your instructions exactly as you wrote them in order to solve the problem that you were given to solve. As you may have heard, computers are dumb. They only do what people tell them to do. So the student receiving your instruction surely is not dumb. He or she will be behaving like a computer. So remember that being exact and detailed in stage 1 is important. Okay? It is also important to note that you're going to be practicing group roles in this activity. Okay, unlike the roles that you assume in a unit project, you must stick to these as faithfully as possible because you're going to behave like a computer. Each student is going to assume these roles and trying to go through another student's program. You're going to be a supervisor, a supplier, a worker, and an inspector. So you're going to be acting like a processor, the I/O unit, input-output, a data bus, and a logic unit. Okay, the data you're going to be processing will be blocks, like those used in preschool classrooms. These are going to be the game pieces. Know that look at how they all have attributes like colors, alphabetic or numeric characters, pictures, and these are all important to solve the problem that you've been given. So although I'm going to be using real building blocks and illustrating this concept to you, you're going to be constructing your own out of printouts. I have pushed out to you a document called Building Blocks Block Printables, so you can cut these out and make your own building blocks to use for this exercise. The game board is a grid that has been pushed out to you. This represents memory where data may be moved, stored, or processed. Each student will use the same grid, but you will have different tasks to solve using it. So I've also pushed out to you this document called Building Blocks, the grid game board. Okay, the output of your instructions will be given to you in two forms. The first is a blueprint. Each student will choose a different blueprint, but they will look alike and they'll look just like the grid shown here. You will provide instructions, given the allowed roles indicated on your instruction sheet, to build the towers that you see here. A number indicates how many blocks high the tower must be on the given square. So 2 means it has to be 2 high. So I will push out to you this building blocks blueprint. So all you have to do is use the blueprint that you are assigned or the blueprint that you choose. The second criteria is to match a criterion that is given to you by your teacher or one that you select yourself. In this first example, all the towers must be oriented so that the top is a colored letter. Both the criterion and the blueprint must be matched for a successful solution. So that was this last sheet I pushed out to you called Building Blocks Criteria. So I will show you what all this put together is going to look like. I will use real building blocks, and you'll see how this is going to work. Okay, you're going to assume various roles as you do the project. This is just so you can see how the computer would react to your input when you design a program. So if we were actual computer lab, different people would do these different roles. But in our online classroom, we cannot do this. So you will try out all these roles yourself. There are 4 roles that you will assume. The first is the supervisor. The supervisor is like the computer's CPU. The supervisor is going to interpret the instructions given to them and direct the other members. The supplier is like the input-output function of the computer. The supplier will manage loading and unloading of the data blocks. The worker moves the data blocks around on the grid. The hardware performing this function in a computer is called the bus, like a school bus. It transports the data around the memory. So you see, the worker can only manipulate one block at a time. So the worker only knows about the grid. You know, is it going north or south? Is it going to A, B, or X? But not the blocks. The worker cannot use any personal judgment in selecting, manipulating, or placing the blocks. That's how the computer's data bus acts. And the last role is the inspector. The inspector only answers yes or no. The computer recognizes the lights on or off, right? So the inspector can only answer yes or no questions about the blocks in the inspection zones that are labeled A or B. So we'll learn more about this limit in Unit 3, data representation. But this role equates to a computer's logical unit. So the first thing we're going to do as a group is we're going to write a people program. So now given the roles to guide you, a blueprint, and a criterion, we're going to write instructions that will guide another student to recreate the solution to your task. Remember to be as precise as possible. The supervisor is given the role of following the instructions exactly, so keep that in mind as you construct your series of steps. So what I've done is I've written out the directions. Okay. I selected blueprint A right here, and I wrote in where the X is and where the A and the B is, so it helped me out in writing out my directions. So I chose criteria 1. The top face of each stack must be a colored letter. Now you can make your own building blocks, of course, so you can use that printout. Of course, you're going to have to color one of those sides in a particular color. So if your printer is black and white, like mine is. But here I actually have building blocks, and I'm going to show you how this exercise looks. Now, what does it tell you? In your directions, normally what you have is you have someone being a supervisor, someone being a supplier, someone being a worker, and someone being an inspector. And it gives you the directions of what they're supposed to do. But since there's only one of us, um, and we're doing it slightly differently, you're going to be all these people. So let me show you how this is going to work for you. In the second phase, you will post your programs to the public document in our course for this assignment. So be sure to include your name for 10 points credit. Then execute another student's programs as faithfully as possible. You might have to wait for another student to post. So, I understand that this might take you a little more time. Then you're going to execute another student's program as faithfully as possible. So now you're going to write on the same public document your comments about the following. Does it work? If not, when and why does it fail? How would you fix the student's program? How much interpretation of what the student has written is necessary? Working through this, do you anticipate any problems with your own program? So make sure you're including your name for 10 points more credit for your comment on someone else's program. Be unique, don't copy what somebody else wrote. All these directions I wrote, I'm going to build this. Put a block on X. Move the block to A. Move east 1 square. Move south 1 square. Put a block on X. Move the block to A. Move east 1 square. Move south 1 square on top of the other block. Is the top of the block colored letter? No. If yes, go to step 12. If no, turn the block 1 turn in any direction, then go back to step 9. Step 9. Is the top of the block a colored letter? Yes. If yes, go to step 12. Put a block on X. So I'm going to just start doing this so you get the idea. Okay? So I have followed my directions, all 35 steps. So let's see if my block, it matches my blueprint. Yes, it does. And that's what it looks like. Okay. So what you do is you do this. You write up your plan. Okay. You get it to work, and then you post it to the site. So here's the team document I was talking about in my Google Drive. And here's my instructions. So we at least have one person's solution to put up there. Now go post your own solution. And, Of course, you want to be unique, so you're not going to use blueprint 1 with criterion 1. So you use another blueprint or another criterion or new altogether, right? So post your own solution right here underneath mine. And then in phase 2, try somebody's solution. What were the results? Add your name. Don't forget your name. This section's worth 10 points. The top section's worth 10 points, okay? Answer the following questions. Did the program work? If not, when and why did it fail? How would you fix it? How much interpretation of what the student has written is necessary? Working through this, do you anticipate any problems with your own program? Now, I found a problem with my program, so see if you can find it. All right? So, if you're going to use mine, or you can always use somebody else's, but once again, be unique and do your comments, post your solution up here, and do phase 2 as well. Much of what we learn in this course is directly related to solving problems, much as these, and systematizing or automating them, making them automatic. With programming, we will discuss the 3 pillars of programs: sequence, selections, and repetition. We're going to learn how to break problems down into smaller chunks. Smaller chunks are easy to solve, and we will further break down these smaller chunks into even smaller chunks than that. And we will construct a whole solution from this process. We're going to learn how to break down problems into smaller chunks, solve them, and recombine the results. We will learn in Unit 2, programming is how to make this problem-solving process and how to create a program that accomplishes the task automatically. Now you're ready to do this program all by yourself.